Undersluice gate. Comprehensive explanation. Introduction to undersluice gates. Undersluice gates play a vital role in the regulation and maintenance of river barrages and diversion dams, especially in irrigation systems. They are a critical hydraulic structure designed to manage sediment and regulate flow in rivers and canals. These gates are typically installed at the riverbed level to enable scouring or flushing of sediments and to maintain desired water levels upstream. In water resources engineering, they are a solution to the problem of sedimentation and a key component for efficient irrigation management. Purpose of undersluice gates. The main objectives of undersluice gates are sediment control. Silt and sand carried by river water settle near the canal headworks. These deposits can obstruct water flow and reduce the efficiency of canals. Undersluice gates, when opened, allow high-velocity water to flush sediment away from the intake area, keeping the canal intake clean. Flow regulation. Undersluice gates can be opened or closed to regulate water levels upstream of the dam or barrage. This is essential during both high-flow flood and low-flow conditions to maintain stable operations. Safety. During floods, undersluices can help in controlling water levels by discharging excess water and reducing pressure on the dam or barrage structure. Protecting head regulators. They are typically placed adjacent to canal head regulators to ensure the cleanest and least sediment-laden water is diverted into canals. Location and arrangement. Undersluices are usually located at the lower level near bed level of a dam or barrage, on the upstream side of the canal head regulator, often placed in a group, for example, 3 to 10 gates, depending on the size of the barrage and flow requirements. This location helps in maximum removal of sediment from the approach channel to the head regulator. Components of an undersluice system. Gates. Made of steel, these gates are operated manually or mechanically to open or close flow. Gate hoisting mechanism. Uses either a manual screw or electric motor to lift the gate. Large gates may use hydraulic systems. Trash rack. Prevents debris like wood, plastics, or aquatic plants from entering the canal. Floor protection. Concrete or stone pitching on the floor prevents erosion from high-velocity flow. Guide walls. These walls direct water and sediment flow during flushing. Working principle. The operation of an undersluice gate is based on opening the gate during high river discharge allows high-velocity flow to pass through at the bottom of the riverbed. The velocity near the riverbed is sufficient to pick up and carry away settled silt and sand. This ensures that the area near the canal intake is kept clean of sediment. Undersluices are operated periodically or continuously depending on sediment, load and flow conditions. Design considerations. When designing undersluice gates, engineers consider discharge capacity, calculated using hydraulic formulas such as the orifice or weir flow equation to determine how much water can be passed. Sediment characteristics, size, weight, and deposition rate of silt and sand particles. River flow conditions, peak flood flow, low flow, average discharge, seasonal variation. Structure safety. The floor and foundation must withstand high-velocity scouring. Hydraulic gradient, ensuring proper slope and energy head to allow effective scouring. Types of undersluice gates. Undersluice gates vary in their construction and operation. Vertical lift gates. The most common type. They move up and down in grooves to control flow. Radial crest gates. Curved gates that rotate upward to open. Suitable for large flows. Roller gates. Used in large barrages. They roll along a track and are easy to operate under pressure. Segmental gates. Provide better control in structures exposed to high hydraulic heads. Operation and maintenance. Regular operation. During monsoon or high-flow seasons, gates are opened more frequently to flush out accumulated sediments. Maintenance tasks. Lubrication of hoisting mechanisms. Inspection of gate seals and structural integrity. Cleaning of trash racks. Automation. Modern dams may use SCADA systems for remote and automatic operation of undersluice gates. Advantages of undersluice gates. Improves canal efficiency. Clean water improves irrigation performance. Prevents siltation. Reduces maintenance dredging. Improves lifespan. Protects downstream infrastructure from sediment damage. Flood management provides an additional route for water release during flood events. Limitations and challenges. High cost, initial construction, and gate mechanisms are expensive. Maintenance intensive, requires regular inspection and cleaning. Manual operation risks, if not automated, depends on timely human intervention. Scour risk, poorly designed undersluices may erode riverbed or structure. Uses undersluice gates for sediment management in the Indus River. Helps maintain irrigation for millions of hectares. Though a storage dam, it has intake structures and sediment flushing mechanisms similar to undersluices. Undersluice gates are a crucial hydraulic, especially where irrigation and their thoughtful design can dramatically improve the efficiency of dams. And while they come with maintenance and technological improvements are making as river systems sediment loads due to deforestation, undersluices will remain an essential